graphing exponential functions, and specifically growth and decay functions. And we're going to use word problems to show you how this is used in real life. So here's something to keep in mind. We're going to be graphing today and resetting the window frequently on your calculators. Keep in mind that the X represents the time. It could be in years, it could be hours, but it's time. And the Y will represent the amount. Okay, and the amount of what will depend on the problem. But keep that in mind as we graph. Okay, now if you don't have a calculator at home, just do your best you can without one, and then you'll have one when you get to class. All right, $300 is invested in an account earning 5% interest compounded annually. A, does this represent growth or decay? Now it's earning interest. Is that going up or down? Well, hopefully that note means it's going up. So part A, you would say this would be a growth problem. And what you would say is it's 1 plus whatever the percentage is. Well, this is 5%. As a decimal, it's 0.05. So it's 1 plus 0.5 at a rate of 1.05%. That is our growth. B, write an equation in the form of y equals a b to the x power for the amount in your account after x number of years. Now, remember what we did yesterday. Here's our account. This a represents what is the value of y if x is 0, because remember b to the 0 power is just 1. So let's think about it. A represents the amount in our account at time is 0. Well, what amount of money did we put in the beginning? Well, isn't that what it says here? It's $300. $300 times B. B is the rate of growth. Okay, that's what we calculated right here. So it's 1.05 to the x power. And there's our equation. Now, if our graph is just going to be in quadrant 1, because we're not investing negative amounts of money, so we can't have a negative x. We're not going to have a negative y because we're earning interest. We're not losing money. So we know everything's going to stay up in quadrant 1. Along the y-axis is our money, amount of money, and down here is our years. So again, it's time. And at the 0, 0, this is 0 years. And how long do you think we would invest? Well, you could invest for 20 years plus, right? Now, we said it's growth, so we would say if it starts at $300, we would guess that the curve is going to go up. Okay? So the question is, look at the question on D. Okay? How many years will it take for the investment to double? Well, what would that mean? If I started with $300 to double it, that would mean it makes $600, right? So how long does it take to double? So I know the y then would be 600. What would that x value be? Right there. Okay? I'm going to show you how to find that on the calculator very simply. But before I jump over there, I want you to remember what we've done with our axis. Okay? Along the y-axis, our values are from 300 to 600, right? Nothing below 0. And our x values are from 0 to 20. Okay? This is going to be helpful because we need to adjust our window on the calculator. So let me show you what I mean. Alright, so if I type in my equation in my y equals 300 times 1.05 raised to the x power. Don't jump over to the graph. You're not going to see anything just yet. Now let's go to window. Hit the window button. And we need to adjust our windows. We said our x values represent time. What's the minimum amount of time we're going to have? Well, you're not going to have negative time, so I'm just going to put a negative 1. I should use the negative button down here. Negative 1. All right, the maximum amount of time, let's say we invest for 20 years, and we can make our scale every 5 years. Okay, that's just the tick marks. Now, the y minimum, what's the minimum amount of money in our bank account? Well, again, it's really 0, but I'm going to make it negative 1 just so I can see the axis. And the y maximum, okay, we know we need it to make up to $600. So I'm going to make it up to $700 just for fun. And our scale will be every $100. Okay, the rest of this, don't worry about it. You don't need to mess with that. Now, you should be able to see a graph that shows exponential growth. All right, there it is. Now the question we had on the problem, it says, at how long will it take for it to make $600? Well, if it starts at 300, we need it to get up to 600. So what is the x value there? The easiest way to do that is to draw a horizontal line where y is 600 and see where does it intersect this curve. The way to do that is to put in y equals, put in your next equation down, in the y equals screen, in the next equation down, I'm going to put 600. That's going to draw a horizontal line right across my graph where that happens. So hit graph again. All right. Now, this intersection right here is going to tell me what x value gives me a y value of 600. You could use the table if you wanted, or you can use a quick keystroke thing. And here's what the keystrokes look like. It does this. You say second, trace, which gets you the calculation screen, hit number 5, intersect, and then you're going to hit enter 3 times. 1, 2, 3. And there's my intersection. So it says where x is 14.21, y is 600. So what does that tell me? That tells me that in 14.26 years, that's how long it's going to take to double my money. So from that graph, I know when y was 600, x was 14.26. Okay? So what does that tell me? How many years is it going to take? It's going to take approximately, now this is just an approximation, 14.26 years to double my money at that interest rate. All right, let's try another one. Caffeine is eliminated from the bloodstream at a rate of 12% per hour. A cup of coffee has 150 milligrams of caffeine. Does this represent growth or decay? Well, I hope the word eliminated kind of tells you a little bit that the amount will go down. So that is a decay indicator. So it's a decay problem. Part B. Write an equation in the form of y equals a b to the x. So y equals, all right, a. What is the amount of caffeine when time is 0? That's what you're asking yourself. The amount of caffeine at time is 0 is 150. B is the rate of a change. Now we said it's decaying, right? So in order to find B, you take 1, and we're going to subtract this time. Last time we added our percentage, this time we're subtracting. Well, 12% as a decimal is 0.12. So 1 minus 0.12 gives me 0.88, right? So that's what's going to go in my parentheses. Notice it's less than 1, so it's a decay problem. Raised to the x power. C, I need a graph. Let's think about this. This is time in hours, and this is the amount of caffeine in milligrams, okay? So if I start at 150 milligrams, my curve is going to go down over time, right? Now let's think about how many hours this could take. Well, this could take 0 to, I don't know, 5 hours. Let's just see. Could take more. And 0 milligrams, 150. So the question is then, find out how many hours it will take for half of the caffeine to be eliminated. So what's half the caffeine? Well, if the original caffeine is 150, half is at 75. So when I go to my calculator, I'm going to enter my window, my XY window, and I'm going to find my horizontal line right here. So let's think about our XY window. Our Y is going to be between 0 and 150. Our X is going to be between 0 and, I don't know, we could say 10 hours just to be safe. I don't know how long it takes. Let's just see. So let's go back over to the calculator. And remember, don't hit graph. Go to window. And let's figure out a thing. Okay, the X minimum, remember that's time. We'll just leave it at -1 for now. We were guessing time would be maybe 10 hours. So let's just change it to 10. And we can change our scale, since we're dealing with smaller numbers, to just 1. Y minimum, leave it there at -1. Now our maximum, we know, is the maximum amount of caffeine we have, which is 150. But I'm just going to make it 200 for fun. And what should our scale be? Our scale, you could go by 20s, you could go by 40s, it doesn't matter. Okay, so we have our curve. Now we need to find out how long did it take to get to half the amount of caffeine. So we said that half would be at 75, right? So we go down to our y2. We're going to draw on a horizontal line where y equals 75. Hit graph again, and you're going to have that line drawn. And we're going to use our calculators to help us find this intersection right there, okay, or right here. So remember the keystrokes. You go second, trace, intersect, 5, enter 3 times. 1, 2, 3. If you look at that, it says 5.42 hours. That's when the amount of caffeine is cut in half. So 5.42 hours. Okay, so we found our intersection at 5.42, and that's where y is 75. So this is our time. So we say at approximately 5.42 hours, the amount of caffeine is cut in half. Let's try one more. Tony purchased a rare 1959 Gibson Les Paul guitar in 2008 for $12,000. Experts estimate that its value will increase by 14% per year. Is this growth or decay? Hopefully you get that this is growth. So it's 1 plus 14 as a decimal. 14% is 0.14. Write an equation in the form of y equals, let's write this down. This is growth. Y equals a, b to the x. So y equals, remember a is what is the value at time equals 0? Well, it starts at $12,000. Okay? B is this guy, 1 plus 0.14, 1.14 raised to the x power. C is our graph. Okay? We know it starts at $12,000 and we know it's going to grow. So it's going to make a curve this way. And this is time and this is value. Make sure that you label your axis very clearly. So we're guessing in years here. I don't know, 20 years. So D says, how many years will it take for the value to reach $50,000? So that's our goal here. How long is it going to take to get $50,000? So we need to know what's that X value right there. Okay. So let's think about before we jump to the calculator, let's think about our values for X and Y. Y is going to go from, I don't know, 0 to $50,000. So we're going to have to make our tick marks at like, I don't know, $10,000 a piece. X values, the lowest it gets is 0, because time is not going to be negative. Let's go up to 20, see if that gets us far enough. All right, let's jump to the calculator. Okay, so I put in my equation $12,000 at 1.14% interest raised to the x power, and I need a horizontal line at $50,000. Now, before I graph, I'm going to hit the window. Let's adjust our window. We know x is time, and time is not going to be anything negative. We're just going to leave it there. And we said our years of time could go up to 20, maybe 30 years. It doesn't matter. Go up to 30 if you want. And our scale, we could go by 5s. The y minimum, remember, is the amount. So the lowest amount that we're going to even deal with here is $12,000. But we want to know how high it gets when $50,000. So so I might go up to 60 just so I can see what's going on. And change my scale to, I don't know, $5,000? Or 5,000, yeah, every $5,000 we'll have it do that. All right. And our goal is to find this intersection point right there. Where does that red line intersect the blue curve? So I do second, trace, 5, and enter 3 times. 1, 2, 3. So what does that tell me right there? Where X is 10.89. That's at 10.89 years. That value of the guitar is going to go up to $50,000. Okay, 10.89. So at 10.89 years, this thing is going up to $50,000. All right, so then my answer would be at approximately 10.89 years. That's how long it takes, okay? So I've modeled for you what I'm looking for on these questions. Now, I know I have another example here on your notes page, and I also have another one I wanted you to try on your own, but because the video is long and it takes time to go between the calculator and the video, I'm going to cut it off here, but I would encourage you to try these. We're going to work these in class, and I want to see how you feel about them after you've tried them on your own. Okay, good luck. See you in class.